For the second half of this video, we are going to do balancing these half reactions. Now, these half reactions usually throw people off because everyone looks at this and they say, well, what do you mean? They're balanced. There's one Ag, there's one Ag, there's one Hg, there's one Hg. But that's not how we're balancing them. We're balancing them. We also have to worry about electrons. They are part of matter, and therefore, if the electrons aren't balanced, then the equation is not balanced. So what we have to do is we have to understand that when they're alone, they have oxidation states of 0. Now, the reason that these two don't have an oxidation state is because of what happened. So here's the trick. Normally, in a chemical equation, if you balance it the way you've learned balancing in the past, just traditional balancing of chemical reactions, you will balance the number of electrons gained and lost if it happens to be a redox reaction. So what the Regents likes to do is they will show you an incomplete reaction so that you cannot balance it the normal way, and then you are forced to balance it based on electrons. Basically, here's what happened. This might have been Hg with O, okay? And let's just say this was Ag, I'm just making this up, with F. So we know that F is -1 and O is -2. That makes Hg plus 2 and Ag plus 1. Now, if they did that, you could balance this equation. If they gave you the full compound, you could balance the equation normally and you'd get the answer right. But because of that, what they do is they say, well, I'm not going to show you the O or the F, and I'm just going to show you the element and its charge. So now you are forced to balance it based on electrons. That's what's really going on here. That's why a lot of these don't have full compounds with them. All right. So the ones that don't have charges, you assume are 0. And the ones that do have charges, they were part of a compound. You've got to just use it. Now let's get to work. So here's what you do. You say, okay, Ag went from 0 to +1. How did it do that? Well, it lost 1 electron. And then Hg went from +2 to 0. Well, how did it do that? Well, it gained 2 electrons. So now, how do I balance the fact that one gained 2 and the other only lost 1? I need to make my loss and gain be equal. Well, I use multipliers. So if I multiply the Ag by 2 and the Hg by 1, well, then I'm still going to have gain 2, but then if I multiply this by 2, I'm going to have lose 2. So here's what happens. The 2's go here, and you can leave the 1's blank, or you can write the 1's in. And so balanced would be 1, 2, 1, 2. And again, the reason is it's not the atoms, it's the electrons that the atoms are gaining and losing that we're balancing. So Hg lost or gained 2, so we kept it as a 1, and Ag lost 1, so we had to double it to make it lose 2. That's where the coefficients came from. I'm going to do one more with you, and then that's pretty much it. Okay, so let's do the second one. That makes sense. So 0, 0. What did it do? What did it do? Calcium lost 2, and aluminum gained 3. How do we balance 2 and 3? Well, we multiply the 3's by 2 and the 2's by 3. So, done, balanced. To make things a little bit easier, what we are going to do is we are going to skip 7 and 8. They don't really fit the type of problem that I'm looking to do. They're like a hybrid of full half reactions and this type of problem. So we're just going to cut them off and just not do those. So I want you to do 3, 4, 5, and 6 on this side of the page.